Hey guys, welcome to this video today, and we are going to go over solving rational equations. Solving rational equations. In my class, we've been simplifying, adding, multiplying, dividing, adding, and subtracting rational expressions. Now we're going to solve rational equations. So let's take a look at some of the things that we'll be doing. All right. So we're going to solve rational equations. A rational equation is any equation that has a variable in the denominator. We got to make sure though that the denominator right here is not equal to 0, because if it's equal to 0, bad things happen. All right, so our denominator will never be equal to 0, and we're going to want to make sure that when we solve these, we make sure that our solution doesn't make our value in the denominator equal to 0, because then if it does, we got all kinds of problems, and we'll get to that. Okay, so let's take a look. I do want to say though that we do have rational equations in real life situations. They happen a lot in physics, actually. When we're dealing with photography and we're talking about convection and reflection and refraction. That's what I meant to say. Reflection and refraction of light on lenses. We're going to use, you see right there, 1 over q equals 1 over f minus 1 over p. We also use it in electrical circuits, which again we do in physics, density, chemistry. So it's all, they're used in different places in science. Here are some steps at solving when we solve these rational equations. One thing to note is my big math F word, which in this case is important, is factor. We may need to factor. All right, sometimes we don't, but most of the time, whenever you see a quadratic, squares, things like that, you're going to want to factor, okay? So, and then we're going to check for these things called extraneous solutions. Extraneous, that's kind of a funny word, but extraneous means extra. It doesn't really, it's not a solution that works. It's something that makes our denominator 0, so we're going to call those extraneous solutions. All right, and then we're going to state our solution. So let's take a look at a few examples. So what we want to do is clear our fraction. So we're going to look for the lowest common denominator, and in this case it's going to be 35x, and we're going to multiply each thing that we have here by 35x. All right. That way, when we multiply it by 35x, it's a little 5 there. We're going to go 5x goes into 35x 7 times. All right, so we're going to go 7 times 4, which is 28. 7 goes into 35x 5x times. So we're going to get 2 times 5, which is 10. X equals, x goes into 35x, 35. See, and now we don't have a rational equation to deal with, all right? We don't have any fractions. So this is, simply turns out we're going to add 28 to both sides. What's that? 63. Then divide by negative 10. So x equals negative 63 over 10. All right, we'll leave it like that. All right, we're going to want to check to make sure that this, if we plugged it back in for x, it would work, and it does. It does not give us 0. That's really the big thing, is to check it. One is check to see if it works and makes the statement true, but really you want to check if it makes it equal to 0. If the bot makes the denominator equal to 0. If the denominator is equal to 0, extraneous. All right, so here's a practice problem. So why don't you try that out? Maybe pause me and then try it out. All right, here's a solution. Okay, again, pause, you can write it all down. All right, so let's take a look at this one. Now notice here, we're going to want to factor, right? Like I said, factoring is important, so we're going to have 8 times x minus 5. All right, so you can go back to think about the least common denominator. What does this one need that one doesn't have, right? So, 8 is 2 times 4. So what I would need here is a 2 and a 4, right? So I would have 2 times 4, 2 times 4, top and bottom. All right, this has everything. And then I need a 2 and an x minus 5 over here. Okay, so watch what happens. I'm going to have 8 times 5, which is 40, over 8 times x minus 5, minus 3x over 8 times x minus 5, equals 2, we're going to say 2x minus 10, because we're going to multiply that in, over 8 times x minus 5. Now, these all have common denominators now, so what I'm going to do is I can multiply all of them by the common denominator, which is just going to cancel out the common denominator, which is just going to leave me with 40 minus 3x equals 2x minus 10. So it's really once you get the common denominators all there, you just kind of get rid of them. You don't really need them anymore, okay? Now we're going to solve for x. So let's add 3x this way. Equals 5x minus 10. We're going to add 10. So 50 equals 5x. And then finally, x equals 10. And we're going to want to check this. If I put it in here, yep, that's going to work. If I put it in here, yep, that's going to be fine. All right, we're good. So x equals 10 is our answer. All right, so here's another practice problem for you to try. So pause me right now, and then I will give you the answer. So, okay, here's the answer. All right, so this time it's x plus 4. Notice here it's a little bit different because I multiplied everything by the common denominator in this case, which gives us the same idea that we did before. All right. All right, last one. Here's another practice for you. So why don't you try that one? Okay, I'm unpaused. Here you go. The common denominator in this case was 3 times x minus 2. All right, so here's my last problem here that I'm going to do. I'm going to factor. So I'm going to get x plus 3. Oh, not x plus 3. Sorry. X minus 3 times x minus 4. So we can see here that our common denominator is going to be x minus 3 times x minus 4, because I'm going to want to multiply this one by x minus 4 and this one by x minus 3. So what I'm going to do is I'm just going to multiply each one of them by x minus 3 times x minus 4 to go ahead and clear the fraction, okay? So I'm going to multiply this one by x minus 3 times x minus 4. This one here by x minus 3 times x minus 4. And this one here by x minus 3 times x minus 4. Okay, so what's that going to do? Clear, clear. X minus 3, x minus 3, x minus 4, x minus 4. That's going to leave me with negative 3x plus 4 equals x plus 2 times x minus 4 plus 2 times x minus 3. Okay, now I'm going to have to do all the multiplication out. So let's multiply all this out. I'm going to multiply this using FOIL. So I'm going to get x squared minus 2x minus 8 when it's all said and done. Like terms, guys, right? Now I'm solving a quadratic. Okay, that's out. Negative 14. Bring all that stuff over to this side over here, right? So add 3x minus 4. Add 3x minus 4. So I'm going to get 0 on this side. So I'm going to do x squared plus 3x minus 18 equals 0. Okay, I'm going to factor this. X minus 3, x plus 6. So that's going to give me x equals 3. X equals negative 6. All right, so now I got to check both of them to make sure that they work, and neither of them gives me a 0 in the denominator. So let's check that. If I plug negative 6 in here, I should be okay. If I plug negative 6 in here, I'm okay. If I plug negative 6 in here, good. So negative 6 works. How about 3? If I plug 3 in here, 3 minus 3 is 0. That's a problem. Survey says, no good. Number 3, x equals 3, is called extraneous. All right? So extraneous solutions are not part of our answer. So our only answer here is x equals negative 6. All right, here is 2 more practice problems for you, and then that's it, guys. So here's one. Pause. Here's the answer. All right, so similar. This time I had another extraneous solution, x equals -2. All right, here's another practice problem for you. Did you get it right? I hope so. Okay, guys, that's it for me. Solving rational equations. Bam!